So, El Nino is this periodic warming of the eastern tropical Pacific. And it's real important to talk about the fact it happens in the tropics. It doesn't, El Nino never comes to California. That's always, wait, El Nino is right off. No, it's 3,000 miles away. But it does impact the global weather patterns by affecting the strength of the polar and the subtropical jet streams. And as those move, the average weather patterns also shift. Some years drier, some years wetter. Just like with atmospheric river, El Nino should not be an adjective.
Yeah. Yeah.
You're going to have storms anyway, and they get influenced by atmospheric rivers. But atmospheric rivers are not the storm. Same with El Nino. You have storms during a winter when you have El Nino. Some of those they have a component where, especially if it's a strengthened subtropical or the polar jet gets far enough south, so it's influenced. They're influenced by El Nino, but they're not caused by El Nino.
Yeah, absolutely. And so this year we're looking at a strong El Nino. Do you want to get into what that means for California?
Sure. So maybe let's talk real quickly about the classifications. So the amount of warming that happens in eastern tropical Pacific when it reaches a half degree Celsius or about a degree Fahrenheit warmer than the average over this large several thousand square mile area, the tropical Pacific, then it's classified as an El Nino. When it gets to be more than 1 degree Celsius, then it becomes a moderate El Nino. More than a degree and a half above normal, then it's classified as a strong El Nino. And if it gets over 2 degrees above normal, then it's called a very strong El Nino. The forecast for this year is to take the warming close to that 2.0 region. So, it might end up being the top of the strong or at the bottom of the very strong category. But so up into an area that we've only seen, three other times in the last 70 years. In 1982 and 1983, and then 1997, 98, which is sort of the benchmark a lot of people use for this is what a very strong El Nino looks like in California. But then we go on, the last one was in 2015-16, which was kind of a normal winter in Northern California and below normal in Southern California. So just totally flipped the script on what comes about. And that's what we see all these maps with El Nino, and you'll see these average patterns. You'll see oftentimes the forecast from Climate Prediction Center basically comes out of the El Nino playbook, where you have this swath of above normal rainfall across the southern tier of the United States, warmer and drier in the northern tier of the United States. But those are averages, and that is often very, very misleading, because we have those outliers like 2015-16, which was this strong, very strong El Nino, but it did not fit the mold. There are all sorts of other things going on in the atmosphere at any time. There's a Pacific Decadal Oscillation and Madden-Julian Oscillation and Arctic Oscillation. I call it this whole alphabet soup of different things that are going on. So while El Nino might be the superstar of the game, sometimes somebody will come off the bench and have an influence. And in those years, you don't always get that, what is, quote, that typical El Nino. And we saw that last year with last year's La Nina. It's really a great case study of how things can be very different. The average pattern with La Nina in California is pretty much drier than normal. And then you go to the Pacific Northwest, wetter than normal. Last year, we all know how wet it was throughout the entire state. And so again, showing that, not all El Ninos, not all La Ninas fit the mold. And there's still a lot of question marks about, what influences this year, what the effects of this year's El Nino are going to be. And I'd like to say, come back and ask me in April, and we can talk about it. There are lots of, because the first thing we have to model in looking at something like this, well, how strong is the El Nino going to be? we kind of are seeing that evolving as was first forecast back in the spring, getting up into the strong, possibly the very strong category. But then we have to look at what other things are going on around the planet and how that's going to translate into, for California, most often we think about for wintertime rains. And the models that we look at for the looking out at the seasonal forecasts have been sort of they were in September, they were painting actually a relatively dry season coming up. In the latest forecast coming out, now they're sort of the bulk of those models are looking at a wetter than normal year. There's still lots of time to go and lots of things that can change. And the impacts that we're gonna be seeing, are not, any storms precipitation that we really see certainly in November. And December is sort of when we start seeing those biggest anomalies in the tropics. And so the stronger subtropical jet might be influencing us. So lots of moving parts to keep in place. Whenever I've given lectures or given classes about El Nino, my first slide is a plain black slide with white lettering that says it's complicated.
Yeah, that sums it up perfectly because at least for strong El Ninos, I was going through the data, and the lowest that we've had out of all the years that we had either a strong or very strong was like 73% for the Sacramento River watershed. So it seems like we're at least in for a somewhat decent year, not like heading straight into drought after a wet winter, right?
Yeah, and a lot of it comes down to the context of what where we are with reservoirs being in really good shape right now. You know, a a year of picking up only three quarters, 80% of normal would not be a big deal like it had been for several previous years.
I was going to ask you about 2015, 2016, and going back to the alphabet soup. Um, One of those alphabet soup that we use a lot here is the PNA, because it kind of gives you an idea what you can expect for at least a few weeks ahead. The best idea, at least, of what you can expect. What sort of things went on in 2016? Because I was looking at the maps, and the Pacific Northwest kind of got hammered that year, while Southern California was dry, which is
Right.
obviously the opposite of what we'd expect, right?
Yeah, I mean, it actually looked like a La Nina. And what I saw most that was different that year was besides the strong warming in the, across the equatorial Pacific, there's also quite a bit of warming between 5 degrees north and about 20 degrees north. So, at the boundary of that warmer water, is you sort of have shoved the subtropical jet farther north with the global pressure gradients and temperature gradients. And so, looking back, I would say that was probably the biggest impact was the fact that we were not just looking at this warming in the
Mm.
tropics.
I'm thinking back. I can't remember if that was an eastern-based El Nino or Modoki or Molokai, however you want to say it, El Nino.
It was certainly it was spread out farther to the west. Still lots of warming in the east, but and that would also have an impact on it. This year is sort of looking kind of a little more classic. There's pretty good warming though in the west, and the I forget what from the model the other day that I was looking at was the amount of cold water spreading from the west north of the El Nino area, how that has varied over the last three El Ninos I was talking about.
I was going to ask also about the impacts of snowfall when we get a strong El Nino.
Um, it's we tend to get in the wet strong El Ninos. Um, the fact you have that subtropical component to the jet, the storms are not as cold. You don't have these nice cold, Gulf of Alaska lows dropping down as often during those years. And but you have high precipitation amounts. So you have at the higher elevations, you have more snow, less of a factor, say at Tahoe level, 6,000 feet or so, it's more liquid precipitation over the course of the year. But buried within any of those patterns, you can get this cold outbreak and you get this real good dump, or it can flip the other way as well. You can get a really extended warm period that really can wipe out a lot of good snow.
Yeah, it's hard to explain to people that it just really makes it really depends what snow levels, because like areas like Mammoth are always usually gonna get snow
Oh
because they're
yeah,
so
yeah, it's
high.
always going to snow up there,
Yeah, but like then you get up to like Boreal and Donner Pass, and like it's
and
kind of a
it's
toss up.
a
Like
little
this storm,
iffier, and it's also all that Sierra cement.
yeah, absolutely. Because we're looking at this upcoming storm, which has been a really tough, frustrating forecast all week. And it looks like snow levels are like around 7,200 feet right now, which is like right at pass level. So it's like,
Yeah, yeah.
man, we don't know what's gonna
And
happen.
it's so, it's sitting offshore, sending these little short waves around the upper low, and it's really really tough. Number one, to time out those, and everybody's been backpedaling from what we saw, toward the end of last week. As far as I know, even the GFS ensemble, was looking Bay Area amounts, inch and a half, and now we're down to third of an inch. And only the European ensemble still trying to hang on to keeping it wet, and the NWS blend is trying to keep it wet. But I don't, I need to do more digging into the blend and how the different components, how those get weighted in. Which is there one that is the leading weighted force in what's the final outcomes going to be, especially when you have this huge spread. They're just like this week's storm. There are as many questions as there are answers at this point, and there's lots of moving parts, and it's complicated.